Yay! Good evening, everyone, and welcome back to another lesson with Earthkey English. My name is Gianluigi Nicolosi, and I'm going to be your teacher today. So, today we're going to answer the age old question of what is density? But before we jump into that, please don't forget to give this video a thumbs up. Share it so everybody can learn today for free. And please don't forget, if you have any questions, write them in the comment section right below. All right. So, one of the main programs we have at Earthkey English is our STEAM program. This is where we teach science, technology, engineering, arts, and math. So today we're going to touch on our science topic, and we're going to talk about liquid density. But first, we have to answer two questions. What is a liquid? And what is density? So, let's first answer our question, what is a liquid? So, in the world, there is something called matter. Matter is made up of atoms, for example, hydrogen, oxygen, gold, uranium. There are many different atoms in the world. But today we're going to be talking about water. So water is made up of three atoms, like this. It's called a molecule. Molecule. So every molecule in water, there are three atoms that make one molecule. We know water is also written H2O. So we know H2 means there are two hydrogen atoms, 1, 2, and only one oxygen atom, number 1. So this one molecule with three atoms makes water. So now we have, here we go, is a lovely cup of water. So if I take my water and I boil it in a kettle or on the stove, what happens to the water? It evaporates and creates steam. Steam is what we call a gas. But now, if I take the same water and I put it in the freezer, what does it become? It becomes ice. It becomes very hard, like ice. So now we know water can make three different types of things. It can make a liquid, water. It can make a solid, ice. And it can make a gas, steam. So this is what a liquid is when it is like water. So now we need to answer the question, what is density? Well, Remember our molecules. Density is how tight are the molecules put together. So, for example, when we had ice, it was very hard. So, this means all the molecules are packed very, very tight, just like this. So, it means that there is not a lot of space in between each molecule. And this means it becomes very hard. And this is what we call a solid, ice. So once we take ice out of the freezer and we leave it on the table, what happens? It melts and it becomes water. This is what we call a liquid. The molecules are not so tight together. They have some space between, which means they can move easily between each other. This is why water always takes the shape of what is holding it. And this is what we call a liquid. Now, if we take our liquid and we add some fire and heat and make it boil, it becomes steam, which is a gas. And with our gas, our molecules are very far apart. So they do not work with gravity, and they can float into the air. Air is another type of gas, mixed with oxygen and nitrogen. So, remember, we have ice, which is a solid. We then have water, which is a liquid. And then we have steam, which is a gas. So, now we have our question. Here is our liquid, water. And we have a question. Can they have different densities? Can different liquids be more close together or further apart? What do you think? Write it in the comment section below. All right, so we're going to answer this question for you guys right now. But first, you need to get some things from the kitchen. So very quickly, get a pen, get a piece of paper, and write your list, because we need a cup of water. We need some dishwashing liquid or soap. We need some food coloring to make the water look beautiful. We need some cooking oil. And we also need an empty glass or jar. If you can see through it, even better. We also need an old plastic lid, like a Coca-Cola lid. And we need a battery or a screw or something small, heavy, and metal. Okay. So, now you have your experiment stuff. Are you ready to do a little experiment? Okay. So the first thing we will do is take our water and our food coloring. And let's make our water look beautiful. We only need a few drops. Boing, boing, boing. Oh, it looks like I don't have enough here. Oh, there we go. All right. So now we've got some bluish water. Then here comes the fun part. First, we take our jar, take the lid off. Then we take our dishwashing liquid. And we're going to pour about this much dishwashing liquid in our jar, like this. Go, go, go! Okay, so there we go. We have a nice layer of dishwashing liquid. So, now we need to think, what are we going to add next? We need to add our colored water. So, do you think it will mix together with our dishwashing soap? Or will it stay separate? Write your comments and answers in the comment section below. Okay. So, now we're going to get our water, our jar, and slowly pour some water into our jar. Wow, have a look at that, boys and girls. So we can see there is now a layer of dishwashing liquid or soap and a layer of water. They're not mixing together. So let's see, what can we do? 1 minute. I'm going to quickly make our water better to see. There we go. All right. I've gone to fetch some more food coloring so we can see just how there we go. Okay, that's great. So now look. I just added a little bit more food coloring so you can see the water. And now look at how the water and soap are separate. It's incredible, hey? So we now need to add one more thing. We have our cooking oil. So tell me, do you think your cooking oil is going to be at the top, the bottom, or in the middle between the two? So where do you think the cooking oil will go? At the bottom, at the top, or in the middle? Let's have a look. So get our cooking oil, and slowly add it to our jar. Oh, maybe a little bit faster than that. Okay. And there we go. So look, that's incredible. We now have 1, 2, 3 layers. The oil was at the top, the water in the middle, and the soap at the bottom. Oh, so what does this mean? Well, let's draw and look. So if this is our bottle, we have 3 layers: oil, water, soap. Oil, water, and soap. So with our 3 layers, our soap is at the bottom, then water, then oil. So which is more dense? Yes, it is soap. Soap is a lot more dense than water. Like this. With soap, there are many, many molecules close together. But with water, they're a little more further apart. And with oil at the top, we can see the molecules are even more further apart. So oil is less dense than water. So let's try one more test with our jar. We have 3 layers with 3 different densities: soap at the bottom, water in the middle, and oil at the top. But now we're going to get our battery. And we're going to see, do you think the battery will go in the bottom, in the middle, or at the top? Let's have a look and see. Ready? 3, 2, 1. Wow, look at that. The battery went straight to the bottom. So what does this tell us? It tells us that the battery is even more dense than the soap. And we know this because the battery is a solid, not a liquid. But let's do another test with a solid. Here is a plastic lid, Coca-Cola. I'm going to put it in, but do you think it will be at the bottom, in the middle, or at the top? If you're just joining us now, comment your answers below. Where will this lid go? At the bottom, at the middle, or in the middle, or at the top? Let's have a look. 3, 2, 1. Oh! Well, look at that. We can see our lid is kind of floating at the top of the oil. So what does this mean? We think a solid is more dense than a liquid, but these liquids are below. So this must mean that the plastic lid, the Coca-Cola lid, is less dense than the water and the oil. Interesting, hey? So we have a very dense battery, some medium dense water, some less dense oil, and even less dense plastic lid. Crazy, eh? Science is a beautiful thing. All right. So, to summarize what we learned today, everything is made up of atoms, and atoms joined together are molecules like H2O. Water. Water is a liquid. When we add heat to a liquid, it becomes a gas, like steam. When we freeze a liquid or put water in the freezer, it becomes a solid or ice. A solid. Okay? If something is very dense, it will be at the bottom. If something is less dense, it'll be in the middle. And if something is even less dense, it'll be at the top. So we can see from our beautiful experiment that every liquid and solid has its own density. And we can measure it by mixing them together. All right. So, guys and girls, before we finish off our lesson today, I want to say thank you very, very much for joining our class. If you enjoyed it and want to learn more, please click the link in the in the description below, and you will get a free private lesson with me personally. Okay. Right, guys and girls, thank you very much for our class. Thank you for joining our liquid density experiment. And I hope to see you all again next Sunday at 6 p.m. But thank you, everyone. My name's Gianluigi, and I will see you all next week. Thank you and goodbye.